He just.
This is a mandatory union break?
I always think that the phone is like, why did a math teacher have to buy me? Damn.
All right. So here's the next level change. We split this middle term up. So we're sort of doing this exactly backwards. But now I know what two numbers go in the middle. So 3x squared and the 8 stay the same. How can I rewrite 10x? 6x plus 4x. So what this method does is it takes a 3-term deal that I can't do shit with, it rewrites it into a 4-term deal that is easy. Grouping is definitely relatively easy, right? Maybe. And of course, if I would have changed the 6 and the 4 around, we saw what that would do. It would still work out at the end. So it doesn't matter what order you put the 6 and the 4. So try to finish that out. It's a good review of grouping. Comes out of these two. 3x. Comes out of these two. And I know I'm on the right track. Now, I want you to, this seems so, I don't know how this seems to you. This seems maybe boring or something, but to me it's crazy awesome. I could take 3 terms and make it 4 all frickin' day long. I can't. 10x, isn't that 8x plus 2x? Isn't it 9x plus 1x? Isn't it 13x minus 3x? All that shit is 10x. But the only way to make it 4 terms and the grouping works is by using the numbers I find here. I really want to make that, it's kind of cool. 3 terms, make it 4 because grouping is easy. Can you make it any 4 terms you want? No, you got to get the numbers from there. But then this process is called surefire method because if you can find those numbers, the grouping has to work. Yes?
Can you explain to me how we get to the very end from 3x times x plus 2?
So how many terms are in this line right here?
X. Oh, 2.
2.
Yeah.
What does this term and this term have in common?
X plus 2.
So I can take an x plus 2 out, and then what's left?
X plus 4.
3x.
3x.
Oh yeah, 3x
Plus 4.
Yeah.
And if I, what's x plus 2 times 3x? It's right there. X plus 2 times 4, it's right there. So again, that is just like, how do you do this problem? How do you factor that? What comes out?
A.
A.
Yeah.
And what's left?
3. Yeah, 3x.
What if it would have been a B there? Huh? What if I would have put a B there?
Same thing.
Then it would have been the same thing, just with the B out front. So whatever the shit that is and that is, they would just come out. So what if that was a x plus 2? I don't know. So instead of B, I put x plus 2. All right, it's going to work the same damn way. I like it. Good. So you got to get over x plus b2 being 2 different things. X plus 2 is one number. It's grouped with the parentheses. If I knew x was 7, that's the number 9, right? So it's one thing, not 2. That's the thing our brain doesn't immediately enjoy about this problem. That's why I like to show you, what if it is just one thing? What if it is just one thing? Well, then it works the same way. That's just one thing. It works the exact same way. So what about this problem? What's the first step?
Multiplying the ends.
The other name for this method, by the way, do you see how it's of this form, right? ax squared plus bx plus c. And the first step is a times c, so this is very often called the AC method, right? Which is something this building is like.
I get it.
And here so 5 times 6 is 30, amazingly enough. What multiplies to be 30 adds to be negative 13.
Negative
Okay.
3, negative
10 and 3, they both have to be negative. So that step is very, very familiar to us. That's what we have to do with the other one, but it's just the number I work with comes from this times this. And to be really honest, let me trip your brain a little bit. What's in the front here on this problem we did earlier? What's this? 1. What's 1 times 32? Negative 30 is negative 32. We've always done it. It's just when there's a 1 out front, it doesn't mess anything up. When there's not a 1 out front, it messes shit up. So how do I use this information?
5x squared
Yes. 5x squared
minus 10x.
minus 10x minus 3x. So I just rewrite this in terms of those two. Don't forget the x's. They have to be there for this to make sense. And then you just group. And at this point, grouping, maybe you still don't fully understand it, but it's got to be relatively easy compared to the other stuff we've done. Right? Grouping should be relatively easy. Yes?
Does it end up being?
Maybe. Let's see.
That's what I would say.
What do you get here? What comes out of here?
5.
5?
5x.
X.
Times x minus 2.
Now, what's got to come out of here? Good. I've got to take a negative 3 out. How do I know that? I know this has got to be the same as this. I know this has got to start with x. I've got to take a negative 3 out to make that happen. And what's 6 divided by negative 3?
Negative 2.
Now, real quick, here's a mistake I see. Stop, don't copy this. Somebody does this because they do 6 divided by 3 is 2. I officially can't go any further because is there anything common to these?
Mm-mm.
No.
But then I still get somebody go, all right, let me just write all this shit down. Maybe he'll be happy. There's all the shit, Jeff. It's all shit. All right, sorry. I'm always thinking, maybe somebody's thinking that. It's all big enough shit. So let's try to do that the right way. 30, Jeff, I love you. Today's a weird day, man. I got to lead a meeting this afternoon, and I feel like I'm not quite all here. So we put this up. And we took 5x, that's minus 2, and then we took negative 3, so that's got to change both of those signs. I know I can keep going if those are the same. If those aren't the same, more than likely I made a negative mistake or I didn't take enough out. Maybe I could take 6 instead of a 3 out or something. Oh, no. There could be some that are prime, but not, that would be kind of evil to take it because of that. It would be prime for a different reason. Yeah. That would be prime if there's no other way to rearrange it so it works, yeah. All right, you guys try this last one out. I left the biggest numbers for you, huh? Oh, but what's negative 15 times 2? Negative, it's supposed to be positive. And that's why these don't match.
Right. Because when I was
But that's, you know, that happens so often where they make the number you want,
Yeah.
but only if one of them's negative or something like that.
So it has to be.
That's a little evil. Yeah.
For the, how come you couldn't do as soon as you can't get anything even number?
What do you mean? Sorry.
Like, why did you do?
That's what all this is all about is, so real quick, so we notice that 6 times 35 is 210.
Yep.
And 14 times 15 is 210. So when it starts like this, I could do 6 times 35, get 210, and then I could figure out, well, what adds to 29 and multiply by 210, 14 and 15. So I'm trying to do this step backwards, and then when I group this, it'll become this again. Because notice, that came from that second, see it? So those two numbers that I can break the middle one up as are the ones that make the grouping work to get me back to here. So it's part of the process to multiply the 3 by the 8, because I can't work with the last number, 35. I've got to work with 6 times 35. So when the first number's not a 1 and you can't take it out GCF,
You have to go.
you have to take it into account. You've got to multiply that.
Can you just check it real quick with your eyes?
With my eyes?
Yeah.
With my eye holes. Let me see. I have. You know what I'm talking about?
I do know.
Okay. Yeah, looks good.
Yeah.
Minus 10 plus 1. Yeah. Oh. Where'd you mess up with the? Oh, right there. Okay.
Right.
What's negative 10 plus 20? Positive 10. So you got the negative, positive.
I did.
Yeah.
But did I get the answer right?
The numbers are right. The negative and
Okay.
positive are in the one place.
Okay, so I just oops. Oops. Oopsie. Oopsie.
All right, let me catch up, you guys. So 8 quarters makes 200 pennies. What's up?
The easy way I did that was 8 times negative 100 and then just divided that by 4.
Oh, sure, whatever works.
Just so I didn't have to do like 5 times 4.
But I like any multiplication by 25, we should be able to do pretty quickly.
You did
It's
8
based on quarters.
8 times 100.
You ever gone to the laundromat to do laundry? Then you know quarter math.
Jesus Christ.
Easy peasy.
So happy to actually
I
have
had
a
2
one.
zeros. It's easy.
So what numbers multiply by negative 200 had to be negative 10, 20, and 10? And again, it's not always going to work, but if I see something ending in a 0, I'm going to try 10 times something first. And if it doesn't work, then I worry about it. Which one's got to be negative? 20. So then I write it, 8x squared. I'm going to rewrite the middle like that, and then I can just group. So the surefire method, at the heart of it, wants to take 3 terms and make it 4. Because again, grouping is relatively easy. It's just 2 GCF problems. I don't mean to make you feel bad if you're still having trouble with some GCF, but you desperately should come see me if that's the reality. What comes out of these two?
4x
4x.
times 2x.
And then I want a 2x, so I know I got to take out a 5. Thankfully, it's 2x. And it's right on the edge there. And so I get 2x minus 5, 4x plus 5. You can put that in either order.
Oh, yeah, just
So I really, so there are other methods to do this, but they hide why they work. And I don't want to teach a method that doesn't reinforce.
I should return 30 years, 35 years.
Yeah,
And
that's
search
all.
about
That's
it.
all I want you to do.
And search about it, my teacher and ask him.
Yes, there you go. Yeah. And he would never know. You could just say, I was curious why that works, and then you just give me his email.
Yeah, I'm gonna text you in 35 years. Hey Jeff.
But the funny thing is, a lot of the teachers I've noticed that, all right, so guys, I'm not going to show you this method, but you can, the tutors know it. Some of you guys sounds like you know it. And it's some people call it bottoms up, but I don't know, it could be called something else. And it just involves, the hardest part of this problem really should be getting the negative 20 and 10. It's figuring out those two numbers. After that, you make a grouping problem, which is relatively easy. You with me? But then it reinforces grouping. The other method, you divide negative 20 and 10 by 8, and you see what it reduces to, and then you put this stuff around. Right? And I've seen teachers, I've evaluated teachers that show that to their students, and I ask them later, do you ever tell them why that works? And then they don't know why it works. And as a teacher, I ain't ever going to tell a damn thing to my students that I don't know why it works. Holy shit. So I would hope that your teacher would know why.
Maybe.
But I've seen a lot of teachers that don't even know why it works, and that's pathetic. Just to be blunt, like I always am.
But you never used to
Take a
explain
stand,
why
Jeff.
this-
I should start doing that. Yes. Oh, so let me write that a little bigger. So we got to the point. There's a question about how to go from this last step.
This is 15. This is
Kind of ran out of the room, like didn't give myself a room. All right, so we got to that step, right? Okay. What is this and this? What do they have in common? They both have
right wrist.
a 2x minus
Right
5.
wrist.
You see that? No, watch, again. Let me do this. How do you factor this?
6, 7, 8, 9, 10 minutes.
What do they both have?
12,
A D. So I can take a D out.
16, 17, 18, 19, 20.
Like that,
20
right?
minutes.
GCM. So whatever this and this are, if they're the same, I can take them back out.
How would you say 100?
So these are the same, I can take them out. And then what's
I would
left?
say an hour.
4x plus 5. Oh, no. Did you want to put a d squared there? No. Because there's not two d's, there's one d that was given to both of these. So I undistribute that one d. So I understand why students want to put a d squared there. But then when I get 4x d squared, that's not what I have. I like it. Okay, maybe. So really it's just GCF taking one level up, where it doesn't have to just be d, it could be 2x minus 5. But that is one thing that they both have in common. It works the same way as any other GCF. Woo! All right. Yeah.
All right, great class for today. Let's go.
That's it. Yeah. I
Oh,
agree.
sick. Nice.